Hello class, this is a video tutorial on graphing combined functions, part 1. To sketch combinations of graphs, we can either use a combination of the following. A combined table of values, as seen here, and the more preferable way, and the more examinable way, we're just going to be using the properties of the functions and the combination that we're going to be doing. In this example, we're going to be looking at the sum of two functions. So, given f of x and g of x, let's sketch y is equal to the sum of f and g. Well, with a combined table of values, I hope just looking at this, it's very self-explanatory. We take a range of values. For cubics, you need more. For a linear function like this, you really only need 3 or 2 to be honest. But with a cubic and things with higher degrees, you often need much more, like so. Now, once you have your table of values for f and g, since we're trying to sketch y is equal to the sum of f and g, we literally just take the sum of each of the rows. So negative 48 plus 5 is going to be negative 43. Negative 15 plus 4 is negative 11. 0 plus 3 is 3, and so on. Now from here, we simply take all these points along the bottom row and we plot them and sketch them together. So negative 4, negative 43, that's too negative for me to sketch. Negative 3, negative 11, so I'm looking at this coordinate here. Negative 3, negative 11 is our first point. Negative 2, negative 2, 3. Negative 2, 3. Negative 1, 5. Negative 1. And what's this? 2, 4, 5. 0, 1. 0, 1. 1, negative 3. 2, negative 1. 2, negative 1. And 3, 13. 3, 2, 4, 6, 8, 10, 12. Let's just approximate 13 to be up here somewhere. Now, from these points, I hope you can visualize a cubic being drawn here. It doesn't have to be 100% accurate because we actually can't determine where the turning points are. But if we were to sketch it, I'm going to do it freehand here. Obviously, for you guys, you'd be using a pencil. That's a bit too steep. And just going to connect it all the way up to the top there. Oh, don't mind that little, there we go, much better. There's a little curve in the middle there, but that there is a combined, well, the sum of the two functions. Hopefully that's very straightforward in looking at this. However, the more preferred way and the more examinable way is just taking the two graphs and using the properties of the sum and the functions themselves to sketch the function. So when it comes to the sum of two functions, it can be more accurately graphed without a table of values by just using these points here. So we'll let s of x equal the sum of f and g. When f of a equals g of a, where a is some x value, the sum must equal double of f, so 2 times f of a. I'll demonstrate to you what I mean. When f of a is equal to g of a, That means they are intersecting. And let's say they intersect at the coordinates of a, 1. So f of a is 1, g of a is 1. Because we're taking the sum of 1 and 1, well, 1 plus 1 equals 2. And this is true for any point that we pick, hence why we have 2 times f of a. Let's find these points first in our graph. So let's find the points where f and a are equal. We are essentially looking for points of intersection. So here's the first one, here's the second, here's the third that I can see. Now from these points, we take this height, because remember, function values are really just heights against the x-axis. So we take this height, like so, and we double it, 2 times that function value. So we are up there now. Oops, it wasn't quite at 5. It's a little bit higher than 5. There we are. Likewise with this one, we take this height against x-axis. You can use a ruler for this, and we double it like so. We take that value there. We take this point here, and we double it. So those are the 3 points that we're going to be needing. Let's now look for the next ones. When f of a is equal to 0, so let's imagine 0 here, we're going to add g of x, or g of a. Well, what it says here, the sum when f is 0, well, the sum must equal g. Because think about this, 0 plus g of x, that's just g of x. And vice versa, if g were 0, and we were to add any function value of x, well, that would just be f of x. So in essence, when we have a x-intercept in one of the values, we are simply going to plot the point on the other point. I'll demonstrate to you what I mean here. Let's find the x-intercepts of f, f being the orange function here. So the orange function, let's look for x-intercepts, or the roots. Here's one root here. That means the sum is going to pass through here. Because remember, 0 plus whatever this is, 0 plus 3, well, it's just going to be 3. We actually saw this in the table of values earlier here. When f was 0, the sum was 3, which is just g of x. Hopefully that's a little bit clearer now. So let's find all those points. When f is 0, the sum is going to be where g is. When f is 0, the sum is going to be where g is. And vice versa. When g is 0, so here's g being 0, the sum is going to be at this point here. And there we have it. So we can already see, well, hopefully you can already see a graph forming, something like that. Okay, so let's now address this last point. When f of a is equal to negative g of a, the sum of them is going to be 0. I'll demonstrate to you this using just a few values. Let's say f were 2 and g were negative 2. So 2 plus negative 2, these two cancel, giving us 0. Okay, and vice versa. So let's say f was negative 3 and g were positive 3. Adding these two would give us 0. Now what this looks like in the graph, I'll demonstrate to you here. So it's rather hard to find, but I've got some notes up here in front of me just to make this a little bit quicker. At negative 2.3, 2.5, 2.5 is here, 2.2, let's say 2.3 is approximately here. So let's take the height at 2.3. There we are. That, let's call that height g of x, because it's against g of x. Now, if we were to take the same height, I'm going to duplicate it and move it underneath. Notice, oh, it's not quite there, but notice how it's almost exactly the same height, except it's negative. That's f of x. But notice how this height is equal to this height, but this one is a negative height. Well, because they are equal but of opposite signs, that means it's going to be an x-intercept. So let's just say that that looks to be about, this height here looks to be about 3.5, looks of it, well, not quite, let's say 3.4. And this one looks to be about negative 3.4. And because when we add them, and they're opposite signs, we get an x-intercept. And there we have it there. So I hope that visually makes it a little bit clearer for you, because now we're gonna try and find all these other points. The next one here is at 0.2, so 0.5, 0.25, just a little bit less than 0.5, 0.25. So let's say it's about here. This one here, if I were to duplicate it and move it into the negative, notice how it's, notice how they are actually the same heights but negative. So there's going to be an x-intercept here. And the last point that I've seen is 2.12. So 2.1 is about here. If I were to take that height and duplicate it, not quite, it's 2.1. Let's go a little bit further here. Is it this height? Oops. Let's take that height, take the exact same height and move it into the negative. Oh, not quite there. Well, apparently from the notes that I've got, it says 2.128, 2.5, 2.2, 2.1. It should be that point there. Let's try one more time. Let's take this height. Let's duplicate the height and move it into the negative. It's not quite working. Not quite working as to what visually, but it says in the graph that it should definitely be here. Well, from these points, I hope you can see the graph already forming. Let's try it one more time. And there we go. So I hope that gave you an insight into graphing the sum of the functions using either the table of values, but more preferably using these features of the graph. Hope to see you in the next video. Best of luck.